All right, folks, Bass Action is back in action here. On this page of notes, we are going to look into our library of functions, which most of these you should already know. So what we're going to do on this first page and most of the subsequent pages is I'm going to have you pause the video, fill out as much of the notes as you can, and then restart it, and we'll go through the answers together. Okay, so on our first function here on letter A, we have f of x equals -4. You should already recognize this from as a graph of a line, a nice horizontal line. Few things that might seem unfamiliar to you. The name of this is called a constant simply because it stays at a constant rate the whole way across. We can see graphically that it never crosses the x-axis, so there's no x-intercept. We can see the y-intercept is clearly at 0, -4. Its domain includes all real numbers, but the range is going to be written in a way that we're not as familiar with because we can see that it only has a single y value the entire time. Sometimes this t-chart is a little bit hard for students to understand because there is actually no place in our function to put the x, and that means that we're going to keep this same y value all the way down. The next function that we have on letter B is our identity function. The identity function, when we look at this, sometimes confuses kids a little bit because typically this isn't written f of x equals x. A lot of times we'll just see this as actually y equals x. And that sometimes confuses kids because they look the same. Same on each side, and that throws them off. But that's exactly what our t-chart looks like. Whatever you have for x, you have for y each time. When we plot that, we get a nice line that goes all the way through and actually divides up our coordinate plane on that diagonal. That's going to be helpful for us when we get into our inverse functions later. We can see that our x-intercept and our y-intercept are the same. Our domain and range would include all real numbers for both of those. The last one, sometimes kids want to call this one a parabola. They want to call this the parabola function. This is not a parabola function. The shape of the curve is a parabola, but the name of the function, you'd be more familiar with quadratic most likely. Our textbook calls this the square function. When we evaluate our t-chart that you're familiar with doing, you can see that we get for each x value, we get our one y value, but we can see that we have that same y value a couple times here. So we get, for example, at -2, I get a +4, and at a +2, I get a +4. So that's okay. X and y intercepts, easy to read. Domain, of course, is easy to read from what we've been doing before. We understand there shouldn't be any restrictions, but you can see our range does have a restriction here. It doesn't start until 0, and it includes the 0. We will not be finding our ranges algebraically. We will only be doing our ranges in this course graphically. Okay, we are going to repeat the process on this page where I want you to go ahead and pause the video, complete the page, and then we'll talk through the answers again. Okay, so let's walk through these functions. So on letter D here, we have our square root function, which that should then connect back to the quadratic that you typically call it a quadratic, but our book calls it a square function. It allows us to be able to really link those even in our nomenclature. Now, the other things that we want to think about is our domain. We can see that our domain is something different other than all real numbers. We can see from our table of values here that we had values that were not possible for us to evaluate without getting imaginary numbers. And we can see graphically that our graph does not include all real numbers. Again, our range is going to start at 0 and will continue all the way to positive infinity, even though it's hard for us to see how it's ever going to reach these high values. It's just going to take a really long time to get there. The next function, students sometimes struggle with this one as well. This is our reciprocal function. On our reciprocal function, you can see I just filled these table of values, and we would have to work with our fractions For example, on this one, when I let x equal -1/2, what we're going to want to really think about is 1 times the reciprocal of a -1/2. In other words, 1 times a -2. So if you're kind of struggling with that, that's what I'm doing there. Things that you want to recognize here on our reciprocal function is that there are some asymptotes here. I've drawn those in a different color for you. We do have 2 asymptotes. We are going to spend a couple days just on our rational functions that will include these functions with fractions in them. Our domain is easiest written in this set notation because it's all of my real numbers except for where this asymptote of 0 is. And notice that with my y, range is the y value, so I wrote it with a y in its set notation, and it also includes all real numbers except for where I have this asymptote at y equals 0. Our last function that we have on this page is going to be our absolute value function. On our absolute value function, you all probably are pretty comfortable with recognizing that it's a v. You understand already that each of these negative values in the absolute value function become positive. Its domain is all real numbers, and its range we can see graphically starts at 0 and goes to positive infinity. When we get farther into this, we could actually rewrite the absolute value function as what is called a piecewise function. So we could take this same equation and same function, and we could write it with a piecewise function for each of these 2 sides. All right, on our last page, you should be able to fill out G and H, and then we will walk through together the greatest integer function because that one will be new. So go ahead, pause, fill out G and H, and then we will talk through those answers as well. Okay. To go over the 2 functions that you should be familiar with here, we have our cubic function and our cube root function. You can see that we have filled out our table of values, and I like to look at these 2 functions simultaneously because they are often confused by students. So just graphically, when we're thinking about our mental images of these, the cubic function is going to rise at a very, very fast rate and fall at a very fast rate. And the cube root function is going to flatten out in the left and right or negative and positive direction along the x-axis there. So it's important to notice that behavior. Notice that both the cubic and the cube root functions are odd functions in that they have their origin symmetry. And that idea of even and odd we could apply and analyze in all of our library of functions. In both cases, our x-intercepts and y-intercepts are 0, 0, and in both cases, their domains and range, their domain and range are both negative infinity to positive infinity. So now let's talk about the greatest integer function. This is a new one that you probably haven't seen before. And there is one thing that we need to add to our notes here that for some reason the computer didn't like the notation when it converted it to the PDF. So we are going to add, you can see here where it says f of x equals int of x. That means the greatest integer function of x. And then we have a secondary notation that we can use for this that the computer just dropped off, and it looks like double brackets. Now, mine are a little bit exaggerated here. You'll see them in some other printed things, and yours might actually even appear on your paper. But if you're following along at home and you don't have my handouts, then that might be helpful for you. So the greatest integer function, I'm going to give you a little bit of a spoiler, is often referred to as a step function. So we're going to analyze, where does that named step function look like? We can imagine what a set of stair steps looks like, but let's figure out how this actually works and we would evaluate this. So we're going to make a t-chart here, and we're just going to pick some values. So I can pick 0, and I'm going to pick 0, I'm going to pick 0.5, I'm going to pick 1, I'm going to pick 1.5, and I'm going to pick 2. I'll work with some negative numbers here in a moment. So the way that greatest integer function works is it takes everything and converts it to an integer, but it's going to drop it down. Okay, so if I put 0 into my greatest integer function, I'm going to get a 0. But if I put a 0.5 0.5 into my greatest integer function, it wants to know the greatest integer, so it doesn't round that up the way we would expect it to. It actually is going to take that 0.5 and it's going to say, well, it's not yet that next whole number, so I'm going to keep it at a 0. And then when it gets to 1, now it says, oh, I'm at my next integer, so it's going to give me a 1. Continuing that process, when it gets to 1.5, again, the function says it's not yet the next biggest integer, so it's going to keep it at 1 until it actually reaches the 1. And at 2, it finally reaches that next. So when we graph this, we're going to get that 0.00, and at 0.5, as we move across this piece at 0.5, it's still going to be at 0, and when it gets to 1, it'll jump up to here. So graphically, what this is doing is it's creating a line right here and an open circle at the 1, because that point then jumps up to the next step, hence the name step function. So it's going to continue along this horizontal. When it gets to 2, it will jump to the next step, continue along, it'll give me an open circle, and we'll jump to the next step and continue. Now, when we look at things in the negative direction, those require a little bit more thought, so I'm just going to pick a couple numbers here. So, for example, if I want to do a negative 0.5, so what I'm thinking about here is my x value of negative 0.5 is right here. And it doesn't want to take that up to 0. It's going to keep it down here at a lower value. So I can imagine these steps going backwards. So this, of course, would have an open circle and it would go backwards. And this would have an open circle and it would go backwards. And this would have an open circle and it would go backwards. So that's going to be our step function. And we're going to do some transformations with this as well. Our domain, we can see that all real numbers are acceptable, negative infinity to positive infinity. Our range, we're going to write in a set notation in a slightly different way. We're going to say y such that y is any integer, because we only get integer values when we're working with the greatest integer function. And that's all I have on our library of functions, and then we'll start working with some examples.